So we talked at the end of last Friday, we talked about our different lengths and where they came from and how they were measured. We talked about our standard lengths, the inch, how it came from a thumb, and of course the foot, and all those measurements going up and their different origins. And we mentioned that King Edward declared that his thumb and his foot were going to be the standards for all measurement throughout his kingdom. And how that was actually a huge advancement in measurement, because that then, now that we had a standardized object for measurement, we didn't need different units because you didn't have to get your foot lined up with something to measure it. You could line up with that block or whatever they used. So today we're going to take that next step, looking at doing our conversions. If we have 48 inches and I want to convert that into feet, most of you could tell me that's how many feet? Or maybe most of you can tell me. 4, very good. You know, looking at that, it's just, well, there's 12 inches in a foot. We're going to divide by 12. But if we didn't know off the top of our heads how to do that, the way we would set that up, we'd take 48 inches and we would make it into a fraction by putting it over 1. Then we'd use a conversion factor. It's called a unity fraction. Now we've seen these unity fractions before. If you recall, back when we were doing fractions, if I had a fraction like 3/4 and I wanted to rename it, I could multiply by 5 over 5. 3 times 5 is 15. 4 times 5 is 20. 15/20 and 3/4 have exactly the same value. And the reason we were able to do that is 5 over 5 is equal to 1. The numerator and the denominator have the same value. And that is what we call a unity fraction. It's equal to 1 because the numerator and denominator have the same value. Well, when we're doing measurement conversions, our unity fractions look a little bit different. We have this relationship that 1 foot equals 12 inches. We're going to use that to create our unity fraction. Now here we're trying to get rid of inches. So we're going to use our rules of fractions to get rid of inches. If I have inches on bottom here, that unit of inches will cross cancel when I do my multiplication. So since I'm working with inches and feet, I'll put feet on top. 1 foot equals 12 inches. Now when we look at this fraction here, it doesn't look like a unity fraction at first. It doesn't look like it's equal to 1. But if you look closely, the numerator, 1 foot, is equal to, has the same value as the denominator of 12 inches. So when we multiply by that, as we said, the inches will cancel out. On top, you've got 48 times 1 foot is 48 feet. On bottom, you've got 1 times 12 is 12. And then you just divide them out. 48 feet divided by 12 is 4 feet. Now, as we said, most of you could do that in your head. You didn't need to write out some big, long conversion. But what if we were using units that you weren't so familiar with? For example, let's say I told you I have 99 feet. I want to convert it into rods. But off the top of our heads, we don't really know that conversion right away. But we can write out 99 feet over 1. And we're going to create a conversion factor, a unity fraction. Now we have feet here that we're trying to get rid of, so I'm going to put feet on bottom so that they'll cross cancel out. The units have to go on top. Well, I'm comparing feet to rods, so it has to be rods on top. Does anybody remember the relationship between rods and feet? 1 rod equals how many feet? I heard someone starting to mumble it there. 16.5, 16 and a half. There's 16 and a half rods in a foot. So back over here, 1 rod, 16.5. So now the feet do cross cancel out. 99 times 1 rod is 99 rods. 1 times 16.5 is 16.5. And we divide it out. 99 divided by 16.5 is, what, 6 rods. So that conversion factor is very handy, using that whole idea of a unity fraction to do our conversions, especially when we're dealing with units that we're not familiar with. We could be dealing, very, very important when we start dealing with going from metric into standard. For example, we know that, or you might be told that 1 inch is equal to 2.54 centimeters. Well, using that, let's say that you are 6 foot 1 inches tall. Well, to do anything with that as far as a conversion, we have to have that all into inches. Now, we're not going to do a formal conversion here. We're just going to do it quick because we're good with feet and inches. 6 feet is how many inches? Well, you do 6 times 12, which is 72. Very good. Plus the 1 is 73 inches. So if you're 6 foot 1, you're 73 inches tall. If we want to convert that into centimeters, 73 inches over 1. What units is going to go on the bottom of this unity fraction? I'm trying to get rid of inches. I'm putting inches on the bottom so they'll cross cancel out. What unit is going to go on top here? If I'm converting 6 foot 1 into centimeters. Converting it into centimeters, so that has to go on top. Now we know 1 inch is 2.54 centimeters. So the inches will cross cancel. We have 73 times 2.54. 185.42 centimeters. And on bottom, 1 times 1 is 1. So that's just 185.42 centimeters. Okay, so if I were to tell you that we're going to build a house and we are going to space the studs at 40 centimeters, is that going to be more or less than our 16-inch stud spacing that's standard? In your notes, I want you guys to quickly try to convert that into inches for me. We'll look at that in just, I'll give you about 30 seconds to see if you can make that conversion. So what unit goes on the bottom here for our unity fraction? Centimeters, good. So the inches have to go on top. 1 inch is 2.54 centimeters. So the centimeters cancel out. 40 times 1 inch is 40 inches. 1 times 2.54 is 2.54. So it's 2.40 divided by 2.54. We're at 15.75, we'll call it, inches. So 40 centimeter spacing is slightly less than our 16-inch spacing. We might look at, let's say that you live 6 miles from, let's just say from school. Let's figure out how many kilometers that would be. Well, I need to give you an equivalence, a relationship between miles and kilometers. I'm going to give you that 1 kilometer is approximately 0.6 miles. So 6 miles over 1. Again, we're getting rid of miles, so I'll put miles on bottom, kilometers on top, 1 mile, 0.6 kilometers. Miles will cancel. Now at this point, you may have noticed a pattern when we're doing these conversions. There's always going to be 1 somewhere in that unity fraction. The larger unit is always going to be the 1. 1 inch is 2.54 centimeters. 1 mile is 0.6. Oops, I did that wrong. Actually, this one I did backwards anyway. I gave the wrong conversion. That's okay. 1 kilometer is 0.6 miles. So that's one of the few cases where the larger unit was not the 1. When we start looking at units of area and units of volume, we're always going to have the larger unit be the 1, and the other one will be whatever number it comes out to be as an equivalent. But also you may have noticed as we're doing this, when we're doing this, they said one of those values is always 1 in our unity fraction. If the other value is on bottom, we end up taking our beginning measurement and dividing by that value. If our other value is on top, here the 1 was on bottom of our unity fraction, the 2.54 was on top. If that other value is on top, we end up taking our beginning measurement and multiplying by that value to get the result. So here, it's going to be 6 miles. Is it going to be multiplied or divided by 0.6? It'll be divided by 0.6. Just to confirm that, we got 6 times 1 kilometer is 6 kilometers. 1 times 0.6 is 0.6. You can see we're going to divide. So 6 miles is about 10 kilometers. So some things that we're going to use these measurements for. We might find (8 feet 3 inches) plus 4 feet 7 inches. When we go to add measurements, especially when we're dealing with standard units, we tend to use this dual unit system, feet and inches. May even have pounds and ounces when we're talking about weight later on. Because of that dual unit system, we got to keep track of what we're doing, just like we would with whole numbers. But, we line them up just like we did ones, tens, and hundreds in our place values for whole numbers. Inches over inches, feet over feet. Then just like any other measurement, we start on the right, we work our way back to the left. So 3 inches plus 7 inches makes 10 inches. Do I have to carry the 1? No, why not? Because we don't carry the 1 until it gets to be 12 inches. 12 inches makes a foot, so we don't carry it until we get a whole foot. So 8 feet and 4 feet makes 12 feet. So we get 12 feet, 10 inches. It doesn't stay that simple. We might have 7 feet, 9 inches plus 6 feet, 10 inches. Again, we'll start on the right, work our way back to the left. 9 inches and 10 inches makes 19 inches. That is bigger than a foot. So if we take out a foot, remember a foot's 12 inches, how many inches are left? Yeah, 19 minus 12 leaves us 7 inches. So what we're going to do here is we're going to keep the inches, keep the 7 inches, and carry our 1 foot. 1 and 7 makes 8, plus 6 is 14. So 14 feet, 7 inches. We might have 6 yards, 2 feet, plus 4 yards and 2 feet. How many feet are in a yard again? 3. Good. So we do 2 feet plus 2 feet, and we get 4 feet. We know that that is bigger than a yard. So that's 1 yard with how many feet left over? 1. Perfect. Keep the 1 foot. Carry the yard. 1 and 6 make 7. Plus 4 is 11 yards. So 11 yards, 1 foot. Or we might see 5 rods, 4 yards, and 7 rods, 5 yards. How many yards are in a rod? 5.5, 5.5. Remember, 5.5 times 3 is 16.5. There's 16.5 feet in a rod. So we'll go ahead to add here. 4 yards and 5 yards makes 9 yards, which is bigger than a rod. That's 1 rod. If we take out 5.5 yards, how many yards are left over? 3.5 yards. So we're going to keep the 3.5 yards, carry the 1 rod. 1 and 5 makes 6, plus 7 is 13 rods. So 13 rods, 3.5 yards. We can end up with 8 feet 9 inches minus 3 feet 7 inches. And again, just like with whole numbers, we've got to line up the inches and the feet, because when we add or subtract, we can only combine things with the same name. And we are going to start at the right and work our way back to the left. 9 inches minus 7 inches is 2 inches. 8 feet minus 3 feet is 5 feet. So 5 feet 2 inches. Well, just like with addition, it doesn't stay that simple. We got 9 feet 3 inches minus 6 feet 10 inches. So we go to subtract here. 3 minus 10 can't be done. So we have to borrow from the 9. That's going to be 8 feet. How many inches do we have here now? Is it 13? No, say no. It's not 13. We borrowed a foot, which is 12 inches. 3 plus 12 is 15 inches is what we have now. So now we can subtract 15 minus 10 is 5 inches. 8 minus 6 is 2 feet. Any questions? So you might have 7 rods, 2 yards minus 4 rods, 4 yards. We go to subtract. We're going to have to borrow 2 rods. You can't take away 4, or 2 yards. You can't take away 4 yards. So we'll borrow from the 7 rods to make it 6 rods. What do we add to the 2? How many yards are in a rod? 5.5, right? So 2 plus 5.5 is now 7.5 yards. So we've got 7.5 minus 4 is 3.5 yards. 6 minus 4 is 2 rods. Or we could have 7 yards, 1 foot minus 5 yards, 2 feet. 1 foot minus 2 foot can't be done, so we're going to borrow from the 7 yards. This becomes 6 yards. How many feet does this become? 4. 1 yard is 3 feet, so 1 plus 3 is 4 feet. Now 4 minus 2 is 2 feet. 6 yards minus 5 yards is 1 yard. Now, we might take a peek at multiplication. When we multiply, in fact, I'm going to show it like this here quick. We could multiply two measurements, like 8 feet 3 inches by 3 feet 6 inches. But if we were multiplying two measurements, two length measurements like that, we don't leave it in the compound units, the dual units like that of feet and inches. We would either convert it all into inches or all into feet. So if I wanted to convert this all into inches, what would I do? Well, 8 times 12 is 96 plus 3. That's 99 inches. For my 3 foot 6 inches, what do I get for inches? Well, 3 foot, 3 times 12 is how many inches? 36 plus 6 is 42 inches. Very good. So now we go ahead and multiply 99 inches times 42 inches. Should give us 378. Oops, screwed that up. 4158. Good thing I punched it in. 4,158. Now remember, when we multiply, we also combine the names. Inches times inches is inches squared. Or our other option was to convert everything to feet. The easiest way to convert them to feet is to use fractions. 8 feet 3 inches is 8 3/12 of a foot, which is 8 1/4. I'm going to put it down as 8.25 feet. 3 foot 6 inches is 3 6/12 of a foot, which is 3 1/2. I'm going to put it down as 3.5 feet. 3.5 feet. So 8.25 times 3.5. 28.875. And again, we multiply the names. Feet times feet are feet squared, or square feet. Now, if we look at these, 28.875 square feet and 4,158 square inches. If I wanted to convert those, 1 foot is 12 inches, right? So I do the 28.875 times 12. Is that going to give me the right answer? No, it's only 346. Why did that not give me 4,158? Well, because this is not feet and inches. It is square feet and square inches. Technically, I'd have to do that conversion again. Multiply by 12 a second time, it actually does come out, 4158. This is something we'll talk more about later. When we have units of area, like square feet and square inches, the conversion factors change. We have a couple of options we'll go through. Now, we could have, I said we don't, we avoid multiplying in the dual units. We could have multiplied there, just like we did with our fractions, though. Remember, you have to do the inches times inches, but you also have to do the inches times feet. So you'll end up with square inches and square feet, but you're also going to end up with some unit, like an inch foot or a foot inch, which is actually a unit. We just don't use it for anything anymore. It's defined to be a unit of area 1 inch wide and 1 foot long, but there's nothing we use it for anymore. And if we did try to multiply it out that way, it's just going to make things more confusing on us. So when we're multiplying one measurement times another, we convert it into a single unit. In this case, it either had to be all inches or all feet. As I said, we're going to come back to this conversion more later. For now, let's look at a measurement times what's called a scalar. A scalar number is nothing more than like a counting number. If I asked how many students are in the class right now, I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, maybe 10 and a half. Looks like somebody's almost asleep there. But there he is. It's a counting number. There's no measurement. Remember, measurements, as we discussed last week and the week before, always have a potential for error. We're going to the closest marking on that measuring device. A scalar is an exact number. So if I want to multiply, let's say I need pieces that are 3 feet, 8 inches long, and I am going to need 7 of them. So if I want to figure out what's the total length of material that I need. Some people would convert this all into inches and multiply it and then convert it back into feet and inches, which would work fine. We're going to go ahead and we're going to work with it just like this in the dual units. So we're going to do 7 times the 8 inches. 7 times 8 is 56. So that's 56 inches. So we have to break this into feet and inches now. How many feet are in 56 inches? Well, 4 feet is 48 inches. If I subtract 48 inches, I'm left with 8. So 4 feet with 8 inches left over. So I'm going to keep my 8 inches, and I'm going to carry my 4 feet. Now we've got the 7 times 3 feet. 7 times 3 is 21. 21 plus 4 is 25 feet. So the carrying works just like it did with whole numbers. So we might have 5 feet, 7 and 1/4 inch times, let's just go times 9. So if we do this, we've got to do 7 and 1/4 times 9. 7 and 1/4 times 9 will be 65 and 1/4. If you don't know that by looking at it, what are your options? Well, you have the fraction calculators for many of you, so you could punch it in there and get it. For mine, I'm going to have to do 7 and 1/4 is 7.25, not divided by, sorry, times 9. And it does, oops, times 9. It does give me 65.25, or 65 and 1/4 inch. So now the question is how do I break that back down into feet and inches? Well, think of fractions. When we went to reduce a fraction or to change it from an improper fraction to a mixed number, we did a division, or we did a division and remainder. When we're going from inches and trying to get it into feet and inches, we're going to divide by 12 because there's 12 inches in a foot. Well, 12 goes into 60 5 times. 5 times 12 is 60. That leaves us with 5 1/4. So this is 5 feet and 5 1/4 inches. So up here, I'm going to keep the 5 1/4 inches, and I'm going to carry the 5 feet. Now I've still got 9 times 5 is 45, plus 5 is 50. So 50 feet, 5 1/4 inches. We might have 3 yards, 2 feet times 5. So we start out with 5 times 2 feet makes 10 feet. Well, how many yards go into that? How many times does 3 go into 10? 3, so it'll be 3 yards with how much left over? 1 foot. 3 times 3 would be 9, so out of 10 there's 1 left over. So I keep the 1 foot and I carry the 3 yards. 5 times 3 is 15, plus the 3 that we carried is 18 yards. Let's take a peek at possibly 5 rods, 4.5 yards times 3. 3 times 4.5 is 13.5 yards. So now we've got to do a similar thing. We've got to reduce that down and figure out how many rods we can get out of that. So there's 5.5 yards in a rod, so we're going to take that divided by 5.5. Well, just by looking at it, we can see probably about 2. 5.5 times 2 is 11, with 2.5 left over. So that is 2 rods with 2.5 yards left over. So over here, we're going to keep the 2.5 yards. We're going to carry the 2 rods. 3 times 5 is 15, plus 2 is 17 rods. So 17 rods, 2.5 yards. Division. Division is the one operation, if you recall, that we work from left to right. So let's say I have something like 27 feet 8 inches. So I have a piece of material that's 27 feet 8 inches and I need to cut it into 4 equal pieces. How long will each piece be? Well, 4 goes into 27 6 times. So I'm going to label that as 6 feet. 6 feet times 4 is 24 feet. And I subtract. 27 minus 24 gives me 3 feet. Now, this is where I would normally bring down the next number. But before I do that here, I have to convert my feet into inches. So when I bring down that next number, they can be combined. 3 feet is 36 inches. So now I can bring down my 8 inches. 8 and 36 make 44 inches. 44 divided by 4, it's 11 inches. So if I had 27 feet 8 inches, if I cut it into 4 equal pieces, it's going to be 6 feet and 11 inches. Now, once again, there are people that a lot of people would prefer to change this all into inches, divide it, and then convert it back. Let's take a look at what that would look like. First, we would have to start with the 27 feet 8 inches and convert it all into inches. I'd start out by doing 27 times 12, which is what, 324? $324. That's the 27 feet. Plus the 8 inches is now 332 inches. So this is going to become 332 inches divided by 4. Well, 4 does not go into 3, so leave it blank above the 3. 4 goes into 33, 8 times. 8 times 4 is 32 with 1 left over. Bring down the 2. 4 goes into 12, 3 times. 3 times 4 is 12. There's nothing left over. So we've got 83 inches is our result there. But we would like to put that back into our dual units, feet and inches. So let's go ahead and do that. 83 inches divided by 12 to give us feet. 12 goes into 83 6 times. 6 times 12 is 72. Subtracting gives me 11 left over. So that is 6 feet, 11 inches. So we put that together. It's 6 feet and 11 inches. So you can see we get the same answer. To me, it's actually a lot less work to do it this way. Now I realize you have the calculator and you're going to use it. So for this problem, 27 foot 8 inches. Divided by 4. I want to point out some things to be careful of here. First thing we're going to do is we're going to take our 27 feet and convert it into inches. So 27 times 12. And we can just go ahead and add our 8 inches onto that. So we'll turn the 27 times 12 to make that inches and then add the 8 inches to it. So it gives us 332 inches. Now we're going to divide that by 4. We get our 83 inches. Now we had mentioned we have to convert that back into feet and inches. So on the calculator, if you have a measurement in inches, like the 83, what you can do to convert that back, you divide by 12. 6.9166667. What this is telling us is that we have 6 whole feet. So I'm going to go ahead and I'm going to write down 6 feet. Now back on the calculator, this next step is important. You're going to subtract that 6 whole feet to get 0.9166667. That is what was left over after we took out this 6 whole feet. We want to convert that back into inches now. So you're going to multiply by 12. Makes it 11 inches. That's going to be a very common exercise for us to either take decimal feet and put it into feet and inches and a fraction, or to take decimal inches and can turn it into feet, inches, and whatever fraction. What if it doesn't divide out nice and perfect? What if we have 30 feet, 5 inches? We want to divide it by 7. Let's do 8. Make it easier on ourselves. So we want to do it into 8 equal pieces. So 8 goes into 30 3 times. It's 3 feet. 3 feet times 8 is 24 feet. We got 6 feet left over. What's left over here, remember, always has to be smaller than what we're dividing by. So before I bring down my 5, what do I have to do to the 6? Turn it into 72 inches. So 5 plus 72 is 82 inches. 82 divided by 8. 8 goes into 82. If I punched it in, 10.25 times. So I either leave it as 10.25 or I can change it to 10 1/4 inches, which is the more common way of seeing it. Okay, so a couple of things I want to make sure we go through here now. What if this didn't come out to 0.25, so it's 10 1/4 inches? What if that came out to 8.367 inches or something silly like that? How can I convert that into something useful? I mean, 0.367 does not appear on our tape measure anywhere. So we need to be able to convert this into something we can read on our tape measure. So let's say that we are going to go to the nearest 16th. We talked about this a little bit before. Going to the nearest 16th of an inch, the whole inches isn't going to change. We've got 8 whole inches. It's that fraction, the decimal, 0.367, that we're going to work with. We're going to put it over 1. What are we going to multiply by? Do you remember? Well, right now we've got a denominator of 1. We want it to be 16, so we have to multiply by 16. Whatever we multiply by on bottom, we have to multiply by on top. 1 times 16 is 16. 0.367 times 16 is 5.872. Now, if you recall, that is telling us that this is between 5/16 and 6/16. Which one's it closer to, 5 or 6? Well, it's 5.8. 8 would indicate that we rounded up to 6, wouldn't it? So we're closer to the 6/16. Now, I'm not going to write it as 6/16 because if you look in your toolbox for a 6/16 inch wrench or whatever, you're not going to find it. In your toolbox, it'll be labeled as 3/8 of an inch. Okay. So let's say we have a room that measures 9 feet 8 inches by 13 feet 5 inches. And I want to know how much baseboard molding it's going to take to go around that room. Well, we're going to have to add some measurements up. Got 13 feet 5 inches plus 9 feet 8 inches. What's that going to get us? Well, 5 inches plus 8 inches is 13 inches, which is more than a foot. It's 1 foot and how many inches left over? 13 minus 12 is 1 inch left over. So I've got my 1 inch. I'm going to carry my 1 foot. 1 and 13 is 14 plus 9 is 23. So is that my answer? 23 feet, 1 inch? Does that go all the way around? No, that goes from here to here, doesn't it? To get the full length of baseboard to go around that room, I have to take that still times 2. Hey guys, somebody's brushing over the microphone. It's causing a lot of background noise for me. There we go, that's better. 2 times 1 inch is 2 inches. 2 times 23 feet is 46 feet. 46 feet, 2 inches. That would be my perimeter. So I'm going to have you guys try one in your notes for me. So let's say we've got a 12-foot, 4-inch room by 16-foot, 11-inch room. Find the amount of molding that would need either crown molding or baseboard, doesn't matter, to go around that room. So our first step, we're going to add those together. Now we could actually, if we wanted to, we could go 16 feet 11 inches and 12 feet 4 inches. And we could add all 4 of those together if we wanted to, going right down the whole pile. For me, it's easier to add them together and then multiply by 2. But if you like adding, you could just go ahead and add them all together like that. So anyway, here we got 11 inches and 4 inches makes 15 inches, which of course is more than a foot. That's 1 foot with 3 inches left over. So we're going to keep our 3 inches, carry the 1 foot. 1 and 16 is 7. Well, technically I should do 1 and 6 is 7 and 2 is 9. Then 1 and 1 is 2. But I can cheat and do 1 and 16 is 17 plus 12 is 29 feet. So we've got 29 feet 3 inches. That goes around 2 of the walls. The other 2 walls are the same size, so I have to double that. So times 2. 2 times 3 inches is 6 inches. 2 times 29 feet is 58 feet. So we got 58 feet 6 inches. Anybody come up with that? Didn't have enough time? Okay, well, if we have a circle, and I ask you to find the perimeter, well, on the circle, the perimeter has a special name. The perimeter is called a circumference. And the circumference of the circle is determined by either its radius, where the radius goes from the center to the outside, or its diameter. A chord attaches 2 parts of the circle, like that. A diameter is just defined to be a chord that contains the center of the circle. Our relationship here, of course, is the diameter is just equal to 2 times the radius. But anyway, back to our circumference. Our circumference, which we're just going to signify with C, if I divide the distance around the circle by the diameter, we get a constant ratio. That ratio, however, is not a nice, neat number. It's 3.1415926, blah, blah, blah. It goes on forever. So we just gave it the name pi. For this class, for pi, you have 2 options. I will typically just punch in 3.14 as pi. But your calculator does also have a pi button. You see mine is over here. I have to hit second and then pi. You can use the pi button on your calculator as well if you want to. But you can see that's a lot more digits to it. It's going to be slightly different. On a quiz or a test, I will figure out the answer both ways, either with the pi button or just using 3.14. And I will accept both answers. So our circumference is equal to that pi thing, that pi number, 3.14, times the length of our diameter. So for this circle, if the diameter is given, let me just draw a new circle. For this circle here, if the diameter is given as 8 inches, the circumference is 3.14, that's pi, times 8 inches, otherwise known as 25.12 inches. So what if I have a half circle? Oops. And let's say this half circle has a radius of, has a diameter of 20 inches. I want to find the perimeter I'm going to go to the nearest eighth inch. Well, to find the perimeter, there's 2 pieces here that I need to do. I need to do the half circle. Then I need to do this straight edge across the diameter. To find the half circle, we make it a whole circle. The circumference of that whole circle will be 3.14 times 20. Times 20 inches. That would end up giving us 62.8 inches. But we don't have the full circle. We only have half of it. So we take our 62.8 inches and we divide it by 2 or multiply it by 1/2. Gives us 31.4 inches. That, however, is not yet our answer because that's just giving us the distance from here to here, the outside edge of the circle. We still have to add back in this distance for that edge of the half circle, the 20 inches. So we do 31.4 inches plus 20 inches is 51.4 inches. Is that our answer? No, why? What else? What do we have to do to it? It's the nearest eighth inch. Good. I could leave that as 51 inches if I wanted to, or I could change it into 4 feet 3 inches and in whatever fraction. For right now, I'm going to leave it as 51. But I need to know what fraction of an inch that is out there to the nearest eighth. So I'm going to take my 0.4 over 1. What do I have to do to it? I have a denominator of 1. I want my denominator to be 8, so I'm going to multiply by 8. I have to do the same on top. 0.4 times 8 is 3.2. That's saying we're between 3/8 and 4/8. Which one are we closer to? 3/8. So this is 51 3/8 inches is that perimeter. Now again, if we wanted to make that into feet, inches, and eighths, 51, notice I'm not even worrying about the fraction. 51 divided by 12, 4 times 12 is 48, with 3 left over. So that is saying it would be 4 feet. That's this number up here is our whole feet. The remainder here is our what's left over for inches, 3 inches. And we got to remember we had the 3/8 inches that we didn't put on. So that one's not bad. I'm going to have you guys try one of those in your notes. Take a half circle, and we're going to give it a radius of 10 inches. Find the perimeter all the way around that half circle. So if we start out with the circumference of a full circle, it would be pi times 10 inches is 31.4 inches. Number pi is 3.14. But that would be the full circle, and we only have half the circle. So we will divide by 2, get 15.7 inches, which goes around here. So now to get the full perimeter, we've got that 15.7 inches, but we still have to put in this 10 inches across here. So it's 25.7 inches. Now, I didn't ask you guys to do it to the nearest eighth, but let's do that. So I got my 25 inches. Let's see how the fraction is. 0.7 over 1 times 8 over 8. 0.7 times 8 is 5.6. So that's between 5 and 6. It's closer to... definitely closer to 6/8. It's 5.6, so it's more than halfway. So 6/8 I can still reduce to 3/4. So yes, even though I did ask for it to the nearest eighth, I still can reduce that to fourths. Any questions? Okay, well, what if we make it one step harder? What if now we have a half circle that we're trying to find the perimeter of? Only now The diameter is given as 4 feet 8 inches. Well, as we said before, when we multiply, at least, we don't stick with our dual units. We're going to have to multiply to find the circumference of the circle. So the first thing I'm going to do is I'm going to change that all into inches. 4 times 12 is 48, plus 8 is 56 inches. So my diameter here is 56 inches. Now if I were looking at the full circle, the circumference would be pi, or 3.14, times the 56-inch diameter. Which is 175.84. And of course, we only want half the circle. We only want to go from here around to here. So divide that by 2. So 87.92 inches is that portion. Are we done? No, we still have to add in this across here, which is the 56 inches. 7 plus 6 is 13. 3 carry the 1. 1 plus 8 is 9. Plus 5 is 14. So 4 carry the 1. 143 feet, or 143.92 inches. So let's see our calculator spits that out at us. 143.92 inches. How do I convert that into feet and inches? And then let's say we're still going to the nearest eighth. Well, I'm going to do this. If I'm starting in inches, so I'm starting in decimal inches, I'm going to divide by 12. So my first step, divide by 12 to get it into feet and record my whole feet. What do I mean by that? Well, right now I have 11.9933333. The 11, the whole number, the part in front of the decimal point, is whole feet. There's 11 whole feet there. Next thing I'm going to do is I've got to account for the fact that I got the 11 whole feet. So I'm going to subtract the whole feet. So I wrote down the 11, so now I'm going to subtract the 11. Gets it back into the leftover pieces of the foot. Step 3, I'm going to multiply by 12, convert it back to inches. So that's saying 11.92 inches. So again, I'm going to record the whole inches. So there's 11 there that I'm going to record. Notice I'm leaving some room because my fraction has to go in with my inches as well. So step 4, I'm going to subtract my whole inches. So I recorded the 11 whole inches. I'll subtract the 11. And then I'm going to convert my whole inches into whatever fraction, or my decimal inches. Convert decimal into fraction of inches. So I wanted this to be to the nearest eighth inch. So I'm going to multiply 0.92 times 8, which is going to be 7.36. So that's saying 7.36 eighths. Is that closer to 7 or closer to 8? It's slightly closer to 7. So that's 11 foot, 8 and 7/8 inches. I'm going to ask you guys to try one of those in your notes for me quick. half circle, 5 foot 2 inch diameter. Calculate the distance around that in feet, inches, and eighths. So your first step would be to convert the 5 foot 2 into whole inches, or just into inches. 5 times 12 is 60, plus the 2 is 62 inches. How many of you got that? So that part good. Okay. The next part, pretend that looks like a circle. That's really ugly. If it were a whole circle, the circumference would be pi 3.14 times 62 inches. $194.68. Now I know, since I know it's half a circle, I'm going to go ahead and divide it by 2. So 97.34. So I divided by 2 to get 97.34 inches. That is this piece up here. What do I still have to do with that? Add my 62. So the 0.34 doesn't change. 7 and 2 makes 9. 9 and 6 is 159. So I have 159.34 inches. I need to make it back into feet, inches, and eighths. So if I had this on my calculator, what would my first step be? I would divide by 12 to turn it into feet. I'm going to get 13 feet. So I'm going to record my whole feet. Then what do? Well, I've recorded my 13 feet, so I'm going to get rid of them. I'm going to subtract 13 feet, leaving me with the leftover fraction of a foot. So now I'm going to turn that back into inches. So times 12. 3.34. So again, I'm going to record my whole inches. I got 3 whole inches there. Once again, I'll subtract off those whole inches of 3 to be left with 0.34. And I'm turning that into eighths, so times 8. 2.72 is closer to 3, so that would be 3/8. So 13 foot, 3 3/8. If we want to do operations with metric measurement, nice thing about metric measurement is they don't do this dual unit junk that we do in standard measurement. Metric measurement, it is either all centimeters, all meters, all whatever. They don't mix them together. So you would never see in the metric system something labeled like 3 meters, 27 centimeters. You're not going to get that combination. It would either be listed as 3.27 meters or 327 centimeters. Because the conversions from one unit to another in the metric system are nice and neat, they don't have any ugliness. Like if I wanted to convert inches into feet into a fraction of a foot, I'm going to end up with some really ugly fractions in most cases. But in the metric system, we're just moving decimal points. So there's no need to have those dual units. So when we're doing an operation in the metric system, all we need to do is make sure we start out with the same units. To do that, to figure out which unit we're going to use, well, let's say we have 4.2 meters plus 370 centimeters. I either have to turn meters into centimeters or centimeters into meters. To know which to do, I need to know what I want my answer in. For example, let's say that I told you that I want my answer in meters. Well, then the 4.2 meters is not going to change. The 370 centimeters is going to become how many meters? Do you remember your conversions? Centimeters to meters on the chart. Meters, decimeters, centimeters. It's 3 spots to the left. Or sorry, 2 spots to the left. My decimal point goes 2 spots to the left. It's 3.7 meters. So now we can just add 4.2 and 3.7 is 7.9 meters. Same with subtraction. We just have to have the same units. If we have something like 38.6 centimeters minus 52.8 millimeters. Let's say I tell you that I want that answer to the nearest millimeter. So now this time, centimeters are going to have to become millimeters. On our chart, millimeters would have been the next number here. Centimeters to millimeters is 1 spot to the right. My decimal point goes 1 spot to the right. So it's 386 millimeters minus 52.8 millimeters, which subtracts out to be what? 333.2 millimeters. Multiplication. Same thing. We want to make sure we have the same units. 7.27 centimeters times 14 millimeters. Well, we need to know what I want the units in for my answer. So let's say it's going to be in centimeters squared. So this will stay 7.2 centimeters times 14 millimeters becomes how many centimeters? 1.4. So 7.2 times 1.4 gives us 10.008. It's going to be centimeters squared. So you guys get the picture there. Division, same way. Now, one thing I want to say about division. When we multiplied, you'll see we combined the units. Centimeters times centimeters became centimeters squared. When we divided, so far, all we've divided by was a scalar. If I have 42 centimeters and I want to divide it into 7 equal pieces, well, 42 divided by 7 is 6, and we kept the centimeters on it. That's because the 7 here has no units. Technically, its label, its name would be ones, and anything divided by 1 is itself. So that's why this unit does not change. But what if we are dividing by a measurement or dividing by something with units on it? Let's take a look at, we can go back to, I'm going to go back to inches for now, just keep it more familiar. Let's say I have 28 square inches divided by 4 inches. Well, I'm going to combine my counts. 28 divided by 4 is 7. But when we multiply or divide, we must also combine the names. Inches squared divided by inches is just inches. So what if I have 32 inches squared and I want to divide it into 8 equal pieces? Oops, not 8 inches, just 8 equal pieces. 32 divided by 8 is 4. What units is my answer going to have? Well, this was inches squared or square inches. There was nothing here. So again, that's ones. So that's going to stay inches squared or square inches. If I have 24 inches divided by 12 inches. Well, 24 divided by 12 is 2. What units go on my answer? There are none. Inches divided by inches goes away. So let's look at what each of these cases would be. This top case up here would be looking at, I have an area that is 28 square inches or inches squared. If one side of that is 4 inches, what must the other side be? Well, that other side must be the 7 inches. This situation here, What that's looking at is, okay, I have 32 square inches, 32 inches squared. If I chop it into 8 equal pieces, how many square inches will each piece be? Each piece here is going to be 4 square inches. This one, this is saying if I have something that is 24 inches long, and I need to cut it into pieces that are 12 inches long, how many of those pieces am I going to get out of it? I'm going to get out of it 2 pieces. The one example I didn't go over yet looks like this. Let's say I have 30 square inches divided by 10 square inches. Come on. Well, 30 divided by 10 is 3. What units are going to go on my answer here? There won't be any, because inches squared divided by inches squared goes away. So again, just like this is just saying 2 pieces, this is just saying 3 pieces. What this is saying is, if I have 30 square inches and I need to cut it into pieces that are each 10 square inches, how many of those pieces am I going to get out of it? I'm going to get 3 of those out of it. Okay, well, I think you guys have had enough for the day. In your little book, I would like you to do Unit 19, the odds. In your big book, you are looking at pages 245 through 247. That's exercise 8-4. 1 through 9. Do the odd again on those. That's dealing with standard measurement. Page 267. Exercise 9-5. There's only 1 through 5 to do there. Do the odds again. That's dealing with metric measurement. And also in the little book, this is going to be Unit 19 and Unit 20, the odds. So now for those of you that are going to be gone on Friday, there's going to be some additional practice with this that you can do. What I gave here is just kind of summary practice, but additional practice. Oops, does everybody have this down?
Write this down, man. No.
Got her down? Okay. So for Friday, some additional practice with our measurements. There's going to be a few of these, so hang in there. Starting on page 239, these are all in the big book, by the way. Starting on page 239, it's exercise 8-2A. Page 240, there's exercise 8-2B. Also on page 40 is exercise 8-2C. And on page 241, you guessed it, exercise 8-2D. On page 242, exercise 8-3A. And page 244, exercise 8-3B. That's for standard measurement. For metric measurement, page 265 through 266, exercise 9-2. So for those of you going on Friday, you're going to have that to do. There will be a quiz for you to make up before you get back, or when you get back. I'll try to remember to send that quiz out tomorrow. So if you get a chance to make it up tomorrow, before you go, you can. Otherwise, you can make it back next week when you get back. Okay, I'll let you guys have the last 7 or 8 minutes here to get started on your homework. And for those of you that are gone on Friday for volleyball, you guys have a great weekend.
All right, thank you.
You bet. Have a good day.